and honor to introduce you all my role model and my guru, Prof V Ramgopal Rao garu. Prof Rao is a co-founder of 2 deep technology startups at IIT Bombay, which have successfully commercially products in the market. Besides his education and research activities, Professor Rao is well known for establishing major nanoelectronics programs in India. Professor Rao's research and leadership contributions have been recognized with over 35 awards and honors in the country and abroad. He is a recipient of 3 honorary doctorates. The recognitions of Professor Rao received include Shanti Swarup Bhatnagar Prize in Engineering Science, Infosys Prize, IEEE EDS Educational Award, that is the highest international award bestowed by IEEE EDS for education, and many other. So thank you, sir. Thank you for accepting our request and coming over. So this is, forum is yours.
Thank you, Dr. Chandrasekhar Garu. This is what India's semiconductor manufacturing mission, is what I believe must look like eventually. It is currently not, what is shown here, but this is what I believe we need to be doing. The focus currently is on this 28 nanometer advanced CMOS, right? That's where government is spending all of its money, and that's what they want to see India emerge as a major, semiconductor manufacturing hub. The target is to capture at least 10% of the global market by 2030. That market will be, let's say, $1 trillion. So India should be at least $100 billion kind of a thing. So that's what the target is. 100 to 2 billion, 200 billion is what India hopes to manufacture, or have a share of that pie by 2030. But I've also been, putting in a way forth my views through all possible ways. I do believe India, in addition to focusing on manufacturing a 28 nanometer node, we should also do a few other things, where we can take a lead. For example, establishing sensor fabs. And fortunately now there is a sensor hub coming up in the country that will come up in Bangalore. So one of the things that will happen as part of the sensor hub is anybody working in the sensors area in the country, if you have shown a proof of concept and if you shown that it works in the field, then you can actually take that to market through the sensor hub. They will provide you funding, they will provide you manufacturing support, and all of that will be available as part of the sensor hub, because India, lot of good research is happening in the sensors area in academic institutions, but how do we take it to the next level? How do we ensure that some products come out of the sensors research in the country? And that's where the sensors fab should happen at some point. And flexible photonics and other kind of fabs. The future is all going to be the flexible kind of displays, the rollable displays, and large area electronics. I think that is again a place where India can take a lead. IIT Kanpur, for example, has a flex center. There is a huge facility in IIT Kanpur for roll-to-roll manufacturing of electronic devices. These are mostly the organic transistor based technologies, and IIT Kanpur has established a very good facility for flexible electronics right now, and they probably have facilities as good as what anybody in the world today has. And then the solar PV fabs, and then the discrete power and RF devices fabs, the GaN fab. IISc Bangalore, for example, is setting up a GaN fab, and there is a big initiative at IISc Bangalore on the GaN. And the packaging fab, this is where Micron, for example, is setting up a big facility in the country. Automotive electronics, analog, BiCMOS, I think this again is a big market because India is a major player in the automotive sector today. I think some of the electronics required for automotive sector is also a place India can take a lead. So I think there are, Mayank is a faculty member at IISc Bangalore. He was my PhD student at IIT Bombay. So he put this together, and I majorly agree with him. So while we will have fabs and more fabs, I think we need to also diversify and take a lead in some of these areas. That's one thing which is very important. So the India, the census is what I will focus on, because I believe that there is a great potential for India to take a lead in the census area, and given the market requirements and demands and all of that. So I will come back to this slide at the end too, after I cover whatever I have in my slides. But this is what is known as the smile curve. It was originally proposed by Stan Shih, right? And what somebody studied was, what this guy studied was, looked at all the different sectors, different industries, and tried to see what exactly is the way, where is the value addition. If you are starting a company today, where does the company make maximum money, right? That's what they actually looked at. And in this respect, the concept and R&D, the product design, the companies which come up with the original product concept, right? They are the ones which actually end up being the most valued kind of companies. Look at, for example, Apple. Apple today's market valuation is what? $3 trillion or so, right? Even NVIDIA, if you look at, right? NVIDIA doesn't manufacture anything. They go to TSMC and other companies for all of their manufacturing, but NVIDIA is like the most valued company now, 3 trillion, kind of a thing right now. But the companies which actually do the manufacturing, right? That is, look at all the Apple's phones are manufactured by Foxconn, and Foxconn market value is $60 billion, $70 billion. So the ones who actually do the manufacturing are valued at 70 billion. The ones which design the products, right, conceptualize the products, are valued at $1 trillion kind of a thing. So Apple, if you see, very strategically they do the branding, they do the design, they do the concept and prototyping, whereas and they also do the sales and after sales kind of a thing. But all the other low end kind of things, they leave it to their partners, right? That's how. And this particular paper, also has a lot of such examples, from different sectors as to how all of these people who came up with the original product idea, right, are the ones who, can strategically leverage those concepts to become the most valued kind of companies. This is there's a lot of study on this smile curve. I think that's what India needs to do. I think we need to come up with a lot of product ideas. As we were also hearing, we need to come up with a lot of these different product kind of ideas. And the IoT, if you talk about, right, the Internet of Things is a very big buzzword. Almost every industry you talk about the IoT kind of a thing. But what exactly is IoT? IoT, of course, the markets are also pretty big. People are talking of trillion sensor visions, right? Now, even in a mobile phone today, there are so many sensors. Right? There are at least 24 sensors inside your mobile phone alone. And each sensor, even if you take it $1 per sensor, you are talking of $1 trillion kind of a market for the sensors alone. If you can capture even 10% of that market, you will still be a big player in this kind of a field. So, and already this area is also growing, and sensors is one area or one kind of a technology through which your electronics becomes intelligent. Otherwise, it's dumb. Right? It's just piece of electronics, some circuits. What intelligence will they have, right? Through sensors, they actually gather information which is around them, and using this information, processing this information intelligently, it can take decisions, and then it will look like a very interesting kind of a thing. I mean, if you have a mobile phone, if you are reading something on the screen, and if the screen turns off, right, that's a dumb phone, right? I mean, the phone should at least know that I am reading something on the screen. It should not turn off, right? But there are so many phones which still turn off just because, even while you are reading something. That's not an intelligent way of designing the phone. You have cameras, and you can actually look at the angle you are holding, and looking at all of that, the phone should at least know that I am reading something. The screen should not turn off kind of a thing. So that's intelligence. And how does that intelligence come from? You can use a camera, which again is a sensor, and or you can use the position that you are holding, and using all of that, you can very accurately predict what you are actually doing with the phone kind of a thing. And or you are in the middle of the meeting, right, in a serious lecture, and suddenly phone rings, And because phone doesn't even know that it's actually now listening to a lecture and should not disturb kind of a thing. But then that's because again, it doesn't know about the surroundings and all of that. That is what about making electronics more intelligent, and that will happen only by integrating more and more sensors into the phone, into any electronic gadget, and then using that information intelligently in order to make a decision kind of a thing, and that will grow, and that will be a $1 trillion market on its own, the IoT. And if you are looking at sensors, there are variety of places we need sensors today, or this intelligent kind of electronics today, right? And even for skill development, you need lot of new systems. The skill development, for example, in BITS Pilani, there is a large distance education exam, distance education kind of learning, which is called the work integrated learning programs. There are something like 50,000 people, students or employees working in various industries who are registered for a degree in BITS, that is known as the work integrated learning program. Now they need to conduct experiments, right? Now these are all working professionals working in industries, and they cannot suddenly come out of their jobs, go somewhere, do some experiment and come back, right? Now, how do they do experiments? No, there is no engineering where you don't gain some hands-on kind of a training. That is where, can you establish IoT laboratories? Now there is a induction motor running in a laboratory, but sitting in my office in Bangalore, can I actually operate this induction motor, record all the readings or whatever that I need to do for that particular experiment, right? So you can now do this distance kind of a laboratories using this IoT kind of sensors. Now you integrate all these sensors around that induction motor, that sitting in Bangalore, I have a real feel of, I can change all the parameters of the motor is physically running here, I can see the motor, I can record everything, I can take all the readings. That is what is where IoT will also be required, and that's again a very big area for distance learning. In fact, AICTE recently, the chairman was there in BITS Pilani. He looked at these labs. He said there are so many institutions in the country which don't have basic experiments, conducted for their BTech students. So can we enable these laboratories for all of these colleges which are in the remote areas kind of a thing? So I think these are the kinds of possibilities where again you can use IoT and sensors. And then agriculture is again another very big area, because agriculture, hardly anything has happened. Over 45% of Indians work in agriculture, dependent on agriculture for their living, and it only contributes about 16%, which is again coming down into the GDP, right? 46% of Indians contributing to 15% of the country's GDP. Whereas if you look at IT, right, IT, less than 1% of Indians work in IT, but it contributes something like 8% to GDP, right? So few people contributing so much more in the IT area, while so many people contributing so less or so little in the agriculture area. Now, how do we correct this problem? The only way to correct the problem is, can you make agriculture productive? How do you make agriculture productive? You need to reduce the input cost, right? You don't need so many people to be doing agriculture. You need to deploy machinery, you need to have sensors. Whatever humans do today, as labor in those fields, should all be done by the machine, so that when fewer people produce the same amount of goods, then everybody, they also will make more money out of that. But for that, lot of automation needs to happen in the agriculture sector, and lot of sensors need to be deployed so that you don't overuse anything. No overuse of water, no overuse of fertilizer. You do a soil testing, and based on the test, you exactly know what the soil needs, and you provide only that nutrient in that quantity required for the soil to actually give you the maximum kind of a productivity. And but that will again call for a lot of sensors today, and there are no such sensors easily available for the farmers. Now again, that's a big area where sensors will be required. Healthcare is again a major concern, right? I mean, Hyderabad, if you go away 100 kilometers from Hyderabad, there is nothing, whereas Hyderabad will have everything, right? I am coming from my native town Kolhapur. Let's say if somebody falls sick there, somebody has a heart problem in Kolhapur. Now where do they go? They have to come to Hyderabad, and Hyderabad is like 180 kilometers away. It will take me 3.5 hours to come to Hyderabad, and for a heart patient who is having a heart attack, bringing that person to Hyderabad for treatment is not going to work out, right? So that's again the place where, can we now have remote diagnostics kind of technologies. Sitting in Hyderabad, the doctors here should be able to at least diagnose, people who are sitting elsewhere, and in the future, even the surgeries are going to be remotely performed. Now there are already a lot of technologies where sitting in Delhi, somebody can perform surgery in Bangalore, right? All of those technologies are already in place. They are still expensive, but the surgeries can be performed remotely right now using robotic kind of tools, and all of these will be the future. And for that, somebody needs to develop technologies, and in fact, every year something like 22 million people, that's 2.2 crore Indians, go below the poverty line because of healthcare expenditure. What is that expenditure primarily? So like I said, somebody in a small town or a village falls sick, the whole family comes to a big city for treatment, and now living in that big city for treatment purposes, the whole family goes below the poverty line. That number in India is 2.2 crore people. And that's the only solution to that is have this healthcare infrastructure spread out, or the doctors in Hyderabad being able to diagnose people in remote locations without having to call them over to these big cities, and eventually even perform all the kind of required medical interventions, provide the medical service from these big cities and all of that. I think some of these will eventually be required, and we need to be doing all of that. And then the security is a major concern, right? If something happens in a train or a bus, how do you prevent it? There is just no way anybody can prevent, because so many people, and it's not possible to do it any other way. So there are, again, we need a lot of security systems which can protect these major installations in the country, or the transport systems and all of that. Energy is again a big issue. The water is a big crisis in India. 4% of the world's water resources is all what we have, and we have 18% of world's population, right? So each of these areas require lot of new technologies, require lot of new solutions, require lot of new products, and who will develop them? I think it's all of us who need to be developing them. We can't expect some Samsungs or to Intel to do all of that for India. I think this is where there is a huge market opportunity for the startups in the country and for academics to contribute. And this is what one needs to be doing. And I would call this as the IoT, the Internet of Things. This is the definition of IoT. The Internet of Things is the network of physical objects which are known as things, but they should have their embedded electronics, they should have their embedded software, embedded sensors, embedded power source, embedded network connectivity. So basically, you have a node that has all of these systems integrated. It's monitoring something, it's also communicating something, it's getting powered on its own. That is when you call it an IoT system. If I want to know what is the air quality in this room, right? I should be able to open my phone, and where some sensor placed here should communicate that information on my phone, and I should know what is the air quality inside this room. With that, I should know whether I should keep the doors open or the air is polluted, what is the quality of air, right? But if that sensor requires a power connection, then I have to now always keep drawing lines everywhere and to put that sensor. That will introduce a huge deployment challenge. But if it is a sensor that is just stuck somewhere, right, in the room, and it's measuring all of these parameters, it gets this power from whatever lighting that you have, or from RF, maybe energy harvesting. There's a lot of RF energy here, or it would get it from the light sources. It would do something on its own that it's powered on its own. It doesn't need to be powered to a socket or anything like that. And it has a communication, it's communicating with mobile phones here, so I know what is happening in this room kind of a thing. I think these are the kinds of things which are known as the IoT, and the future is all going to be those sort of IoT technologies. And whenever you want to develop such a technology, you need a multidisciplinary team. Electrical engineers can barely put together a basic prototype, but then to do anything beyond that, you need the involvement of people from multiple disciplines. So that's where you need multidisciplinary groups for most of these kind of activities. And there are systems available now, the IoT kind of things, which look like a speck of dust, right? You have all of these, you can sprinkle it in an area, and then it will keep monitoring something in that area, right? Those sort of things are already becoming available right now. And the cost is also a very big factor in all of this. If these IoT nodes become expensive, right, then you can't deploy them all over, then the cost will become an issue. But if these things become very low cost, then the deployment will be pretty high, and then you can have these sensors easily accessible and available everywhere. And the world is not a rich place. Though we seem to think that everybody is rich, only we are poor, right? But that's not actually the case. If you look at the World Bank Atlas, right, 80% of humanity in the world lives on less than $10 a day. $300 is all the money 80% of humans make on the planet. 80%, which is already what, $5 billion, 5 billion humans and all of that, make just about $300 a month, right? So that's all what it is, and so that's what we need to be doing. While we are developing these technologies, they need to be made affordable. I think that's one very key requirement for this. And farmers, agriculture to me is a very important area to focus on. And unfortunately, you don't have many engineering departments, engineering schools which have a strong agriculture, kind of departments, right? I mean, all of us, agriculture, you need to go to agricultural universities, but they don't have engineering. And engineering schools need to work on agriculture, but we don't have agriculture departments. That is currently the problem of Indian higher education system. So, and that multidisciplinary universities, as the national education policy talks about, is the need of the hour. And that is where, we must have comprehensive universities which can focus on all of these kinds of aspects. So having said that, so I am a electron devices researcher. I always worked in electron devices. All my projects with all these big multinational companies were on CMOS technologies and the new device concepts and all of that. But around 2005, 2006 kind of a time frame, I started a project called Project on Sensors, because I realized the requirement for some of these, way back in 2004, 2005 kind of a time frame. And then I said, can I start working in some of these areas independent of my other CMOS kind of an activity. And so one of the very first projects we took up at IIT Bombay was in developing a cardiac diagnostic system. So I am an electrical engineer, or rather a microelectronics engineer. So now what do I know about the cardiac system? So I had no idea what a cardiac system was. And then but at IIT Bombay, a few of us formed a group from different departments. In fact, some of this activity, I had my collaborator, Professor Shome Mukherjee, who was a faculty member in the Department of Biomedical Engineering. He is now the director of BITS Pilani Hyderabad campus. We appointed him just about a few months ago. And so we all came together, some of us working in very diverse disciplines. We said, finally, let us develop something related to a cardiac diagnosis, because what essentially happens is, in India, if you look at all of these statistics, things are pretty alarming, right? Almost every, in places like Kerala or even in Andhra Pradesh, you see 1 in 3 patients, 1 in 3 persons die because of cardiac failure. 30% of deaths in India occur because of heart attacks, just because of heart attacks. And the reasons are plenty for that. The reasons are, we are basically an agrarian society. All our grandfathers, great grandfathers were actually farmers, right? And the food that they used to eat, and eat that food, go to the farm, do all the physical activity, right? That was how the entire thing was balanced. But now we eat the same food what our grandfathers were eating, right? But we don't go to farm. We come and sit in front of a computer, right? And we move around in cars, and we hardly do any physical kind of an activity. So as a result, now with the high calorie intake, Indian food is a lot of carbohydrates. Now you eat all of that food and there is no physical kind of an activity, obviously India will suffer from all of these cardiac kind of problems, which is exactly what we are seeing today, in most of the Indian households. But how do you diagnose this cardiac problem, right? If there is a chest pain, and to now know that the chest pain is because of a cardiac problem, not because of any other reason. Chest pain can come because of any reasons, right? Even, simple gas problems can cause chest pain, right? How do I now rule out that the chest pain is not because of a cardiac problem, a heart problem, but because of something else, can cost you a lot of money. I went through that process in Delhi, when I was the director in IIT Delhi. One day while I was going to the office, I had some chest pain, and the chest pain, for whatever reason it was, had some perspiration. Now you tell a doctor that I am having chest pain with perspiration, that rings lot of alarm bells in the medical community. They said that no, we should actually get tested, and we shouldn't take any chance. And then suddenly, instead of going to office, I ended up in a big hospital just outside, because IIT hospitals are also just primary healthcare centers. Other than ECG, they really cannot do anything. Then we ended up in a big private hospital outside, and there were, being director of IIT Delhi, you have certain privileges. So there were doctors waiting outside, and suddenly I was taken inside the ICU, and then they started doing all the measures, like taking ECG. ECG was normal. They started taking all of these cardiac protein tests, like troponin I, CKMB, myoglobin. These are all proteins in the blood. Their concentrations go up if you are having a heart problem. So they started doing those tests, and everything was normal. But they said that we need to wait for some more time, and they kept me in the hospital for almost 12 hours, right? And they were saying that no, we should do more tests. But then I said, it's 12 hours now, everything is normal. I want to go back, right? I don't want to stay in the hospital hoping that something will go wrong kind of a thing, hoping that I will have a result which is negative kind of a thing. I said, if I have a problem, I will come back. But then by the end of the day, when I was leaving, they gave me a bill which actually caused a heart attack for me, because that it was in a 5-star hospital, right, in the ICU for 12 hours today. You know what the costs are going to be, and that is what happens. That is what doctors always wanted. Doctors said, what can you do if somebody comes with a chest pain to me, right? Can I do some simple blood tests in addition to ECG, of course, and rule out cardiac problems? That ideally one should be able to do at home itself. If I have a history of cardiac problem, I should be able to do these blood tests. After all, we do blood tests for sugar measurement at home today. So why can't you do these blood tests at home for these cardiac markers? And if they are high concentration, then obviously you have to rush to a hospital, even if your ECG is normal. That's how the cardiac care actually works. So we said, can we develop those tests for some of these blood samples, for these blood proteins, for home use sort of a thing. Before we go to the home use, at least in MBBS kind of clinics, right? When you have a heart problem, you don't go to an MBBS doctor. Usually you need to go to a super specialty hospital kind of a thing. But very often for us, the nearest clinic is an MBBS doctor. At least if I go to the doctor and the doctor does these tests, I would know what the problem is, and I can decide accordingly where to actually go kind of a thing. So we wanted to develop such a system which would detect at least 2 cardiac markers using the blood sample. And then we made a complete system on chip kind of a design. I mean, we did a complete top-down kind of a design, right? Otherwise, in academic institutions, how do we do research? Most of the times, you don't define the problem from a system point of view, right? Our problems are defined from a publication point of view. If I do this, I can publish this paper. That is how most of the research today in academic institutions we actually do. But in our case, we said, while publications will anyway come out, but we should develop a prototype at the end of the project involving all of these department, faculty, and all that. So then we actually made this block diagram. It was a solution to a problem, right? And so what do you need? You take the blood sample, you need to filter it out, because blood contains so many things which you don't need for this measurement. You are detecting just the proteins. So you need to filter out the blood, and then you have these microfluidic channels, right? With 1 drop of blood, you are monitoring multiple markers in the blood. So you need those microfluidic channels, and then the sensors for the different cardiac proteins. Right? That's this chip. And then this entire thing needs to be disposable, because you are dealing with human blood, so you cannot reuse them. And the moment you say you have to dispose them, then you can't use silicon, because silicon at the end of the day is a very expensive piece of material. It's a very high quality material, but it's also very expensive. You don't use silicon for a use and throw application, right? I mean, one time use of silicon is not really a very cost effective way of using silicon. So since it's a disposable kind of a chip, our approach was to use non-silicon kind of technologies to build this entire platform, and then you have a small tabletop system like your blood glucose, that instrument, which is made out of silicon chips, and all of that is okay. But this diagnostic chip, right? So this cartridge needs to be a disposable kind of a platform. So that was a product definition we did at the very beginning. And we also set a price point. We said this entire test needs to cost about 200 rupees per diagnosis. For every test now, it should not be more than 200 rupees. Now, if it is 200 rupees per test, my entire manufacturing cost needs to be about 50 rupees, 60 rupees kind of a thing. I need to target, in the large scale manufacturing, that kind of a cost for the entire chip to be made. So we made all of this, the design, all of these commercials, all of that worked out. And who is going to use that? It should be in an MBBS clinic. So in an MBBS clinic, the kind of surroundings you have, the kind of people who will do these tests, all of that you need to keep in mind before you actually, launch this as a product kind of a thing. So from an academic institution, with that product kind of an angle, working out all the commercials, thinking of what the final price point needs to be, made the project actually more interesting. The moment we said that the cost of the entire chip needs to be about 50 rupees or 60 rupees, it ruled out many things. Now, in our microelectronics laboratories, we are very generous. We use gold, platinum, anything you name, we will have it, in our laboratories kind of a thing, because we use, platinum for contacts, gold for contacts are not very uncommon in many of those applications. But here, since we wanted to keep the cost very low, and we did not want to use very expensive process techniques. If I require a deep reactive ion etching system that costs about 6 crores or 7 crores, and if I buy that cost eventually needs to be added to, what you are marketing here. Therefore, we did not want such expensive systems. We wanted things which are very simple benchtop kind of technologies for fabrication of many of these sort of chips. So we kept all of that in mind, which was a very new experience for us too as researchers at IIT Bombay. But we were driven by a passion. Our passion was to develop something for societal use kind of a thing. And in my group, while different groups worked on different things, so in my group we started working on these cantilever chips, right, where you make these piezoresistive cantilevers, and any surface reaction here between the proteins and antibodies is what is converted into an electrical signal. So this is the piezoresistive platform, and it doesn't use silicon anywhere. There is no silicon anywhere in this chip. All of that is made by polymers. While we use silicon as a base substrate, but we eventually etch away the chip, right? We lift off the chip completely from the base, that silicon can be reused. So that was how we designed a process. So we did a lot of good research, but the entire goal here is when antibodies bind to those proteins, the cardiac proteins, the change in resistance, which is what you are measuring here, should be measurable, right? If let's say some very low concentration of those antibodies bind to a few proteins which are in the blood, those cardiac proteins, now how much of stress will get developed, how much of that stress I can measure using the piezoresistors, and is it measurable quantity? If I have a 1 mega ohm resistor, what is the lowest value of resistance that I can measure, right? And is my measurement within those limits? That called for a lot of instrumentation, lot of chip design, all of that went as part of this project, in addition to developing the sensors which are sensitive enough to the antibodies binding to that protein. So the project became pretty interesting. We worked on a lot of these interesting ideas. I'll skip all of that because I'm conscious of time. So we made all of this, and we wrote many papers. You will find many papers on my web page, all of these papers that are written. And so at the end of much of this research, right, and all of this platform development, lots of publications, lot of patents, we were able to show a world record in terms of per nanometer of deflection of this cantilever. Why is the cantilever deflecting? Because of the reactions happening on the surface between the antibodies you coated with the proteins in the blood. So, for a nanometer of deflection, which is because of that chemical binding, how much of change in resistance would occur in terms of ppm? So, we showed that we had a world record in terms of ppm per nanometer as compared to anything that other researchers have published, and this was our work, which was pretty good and all of that. So, we did that, and then we developed the entire electronics, because at the end of the day the cantilever is deflecting, which has a piezoresistor embedded in it because of the reaction, and that piezoresistance change you need to be able to monitor, and that again calls for a very sophisticated instrumentation amplifier, and for the measuring the delta R in this particular system. Now, we also wrote multiple papers on current acceleration method for delta R measurement in piezoresistive sensors with 0.3 ppm resolution. So, a lot of such work happened, developed signal conditioning blocks, and developed very sensitive electronics to monitor the delta R kind of values. And then putting all of this together, we made our first prototype, and this was the first prototype for the cardiac diagnosis, and where this is the cartridge where you put a drop of blood, and then it can actually do the detection. It's a real time thing. You can do it in the laboratory. We could develop it for 2 markers. And once it was working well in the laboratory, right, it needs lot of hospital trials. Now, unless you do those trials, it's difficult to launch any of these diagnostic systems. And then we started a company, a NanoSniff Technologies Private Limited, and then we transferred this technology to NanoSniff to further take it forward and commercialize and all of that. But by the end of this project, we were able to develop a platform which could detect surface chemical reactions. Any chemical reaction happening on the surface, we could detect electrically. That was the technology platform we were able to develop. And around that time, there was some security agencies approached us, saying that we heard that you developed this platform. I made this presentation to Professor CNR Rao in Bangalore as part of some committee kind of proposals, and in that committee there was Dr. Baldev Raj, who passed away some time ago, and he was director IGCAR, Indira Gandhi Center for Advanced Research, and so he, for example, looked at this thing and he said, many security agencies need this technology for explosive detection, where currently the gold standard for explosive detection is dog, right? That's the reason why whenever you have an unidentified bag anywhere, it's a dogs that first are brought, and then dogs sniff, and then dogs give indication to the master, there to the security people, whether there is something suspicious or not. And so that is what happens with any detection of any of these banned kind of substances. Dogs have a very high sensitivity as compared to the human nose. Dogs can smell 1,000,000 times better, and therefore, if they are trained to detect that smell, it can always detect many of those sort of smells. But they said they wanted an electronic equivalent of that, right? An electronic nose platform basically, that in electronics which can also smell like a dog. If you look at it, your mobile phone, out of the 5 senses that we talk about as humans through which we gather information, the 3 senses are very well captured in a phone. Phone already can listen, right? Just as we listen, phones also can listen. Phones can see, they have excellent cameras. Phones can also touch. The touch sensitivity in electronics is pretty good now. People are performing remote surgeries, with haptics and other kind of feedback. So, the touch sensitivity is already captured in the mobile phone. What are the 2 senses that we have which the electronics today cannot do? One is smell, right? Though people are talking of electronic nose and all that, electronics still are very dumb when it comes to smelling something. They cannot also taste anything, right? The taste and the smell are 2 senses we humans have, which electronic systems haven't yet got, to the level of degree of sophistication that we humans have. And if these 2 senses can be given to an electronic system, just imagine what a phone can do. Imagine a phone which is also a sniffer dog, right? And because it's an electronic system, you can actually now train the phone to detect whatever smells that you have. You can tell the phone, whenever this guy is not taking bath, alert me, right? Or it will tell you that he's smelling some different way, don't sit next to him, kind of a thing. And so a lot of things can become, or it can behave like a sniffer dog, where if you are traveling in a bus, right, somebody came and put a bag there, and suddenly your phone smells something different. right, it will immediately tell you that there is something suspicious in this bag, right, and you can actually find out, once you get that indication, you can go to the driver and tell, and then you can check the bag and all of that. Imagine how many lives will get saved with things like that. And in fact, some other day, some police people came and said, we want to detect currency, right? People are hiding currencies everywhere. I want an electronic system which can smell currency. So now you can imagine how do you smell currencies, kind of a thing. But that is a kind of a thing, you can do once the smell is captured by electronics. There are infinite possibilities, and taste is equally important, because the taste is used primarily to know the quality of food, right? And by taste, you know whether the food is good quality, bad quality, how old it is. A lot of things are done by taste now. Just imagine, whether you want to standardize tea or you want to standardize any alcoholic drinks. I think if you have good taste sensors, you can actually do a lot of standardization using many of such technologies today. And so this is a big market right now, and we were trying to develop that electronic nose platform specifically for explosive detection. So when you are developing that for explosive detection, then we take these, again the same cantilevers, the platform remains the same, but the coatings are now different. Now for the coatings, I need to detect explosives. Explosives have a vapor pressure. There are some vapors coming out. That's how the dog is able to smell them after all. The same vapor, now my electronic system should be able to capture, right? And then it should be able to react to that smell, that vapor, whatever low concentration it may be, it should be able to react to that smell. So how do you do that? In order to do that, you now take a bunch of these cantilevers, right, and you coat them with molecules which can bind to vapors of explosive, right? And that is where you need to synthesize these molecules. They are not available commercially. So we worked with a lot of chemists in the country, chemists from multiple institutions, including IITs and IISc. We had large meetings at the national level to pose it as a challenge to chemists, saying that can you develop molecules which can selectively bind to explosives and to nothing else. Once you solve the problem of that selective binding, rest of it we can do. The rest of it is all about deflection and all of that. We have already done that. So that selective binding is what we are looking for. So we started fabricating these cantilevers, cantilever arrays, coated with different molecules on the surface, and when explosives come in, explosive vapors come in, they bind to different cantilevers differently, because there are different coatings on the cantilever, and because of the different coatings, each cantilever will respond differently, which is a pattern. So every smell, you are converting that into an electronic pattern, a signal basically. So if I have, let's say 12 cantilevers, each cantilever will behave differently to the same vapor, because they are coated with different molecules, and the difference in behavior is what we capture as an electronic pattern. And that pattern, whenever it appears, you know that that pattern corresponds to this smell, and depending on how many cantilevers you have, you can actually identify that many patterns and all of that. So this is what we did, and this was the very first system we demonstrated, called XSNIF, explosive sensor model. It takes in the air from here, and it has all of those algorithms for pattern recognition. Basically, you are recognizing patterns here. It has arrays of cantilevers, and we transferred this technology to the principal scientific advisor office and got it manufactured in SCL. So a lot of papers, a lot of work again was done in that, and these are all how these cantilevers respond to vapors of explosive. So a lot of work went into that, and subsequently, while we were working on the platform, so we also stumbled upon a very new idea, right? When you are discussing 5 faculty members from 5 different departments, 20 students sit in a room and discuss every day, a lot of new ideas we were looking for explosive detection in this particular case. One of the ideas that came in that meeting was, what is the property of an explosive? The property, in all the technologies I talked about before, there is a reaction. There is a selective reaction between what you coat and what you want to detect. And if that reaction is not selective, you can't really do anything much there. In the electronic nose platform, the reactions are happening differently, so you are capturing a pattern, right? That is also another way of doing that. There the selectivity is not so important. The pattern reproduction is very important in the electronic nose kind of a platform. But one of the ideas we came up during those meetings was, the property of an explosive is to explode. right? And how can you now, so if I want to detect, if I want to know when something is explosive, you collect the vapors, you actually explode them. When you explode, these are all high energy materials, exothermic reactions, they release energy. That energy release is what you measure using a temperature sensor. So essentially what you are doing is a very simple concept. I want to detect explosive, explode. If it explodes, it's an explosive. If it doesn't explode, it's not an explosive. So it doesn't need any great rocket science to do that, right? But then you can't tell a police officer that you exploded. No, I will tell you whether it's explosive or not. Nobody is going to believe that. So therefore you need to explode in nanograms of quantities, right? From the vapor, you collect some 10 nanograms. 10 nanograms, nothing happens, because any material 10 nanograms exploding, nothing happens. But it will actually change some temperature in the surrounding. It will have a thermal signature. If you can capture the thermal signature of a 10 nanogram explosive exploding, then you are in the business. Then you can actually do wonderful things. That is exactly what we did. But how do, in all the previous techniques, again, what was the challenge? There is a smell, right? In many places, particularly Kashmir, right? We gave this technology to security officers. They went and tested it in the field. But one of the problems were, if there is a very strong foul smell, right? Then you can't, even dogs cannot detect anything. In Kashmir kind of places, the terrorists place a bomb and put lot of cow dung around that, right? When they put lot of cow dung, no sensor can actually detect, because the cow dung smell will be so strong that the explosive smell will no dog can be able to detect it. So these are the challenges with any detection based on the sniffing, like what the dogs do. So then we were looking for something beyond that, right? And that's where we actually thought of this idea of causing an explosion to detect the explosive. And I will play a small 2-minute video.
An IIT Bombay incubated company jointly manufacture and launch Nano Sniffer, an advanced and affordable explosive trace detector, screening visitors and passengers for explosives at various public or crowded spots have become the norm due to the increase in the terrorist activities around the globe. Every luggage and person passing through the security checkpoint is tested by the security officer to check whether they have traces of explosives on their surface, skin, or hair. Nano Sniffer proudly claims to be the first explosive trace detector in the world using micro-sensor technology. The micro-sensor of Nano Sniffer is made using micro-electromechanical system, MEMS technology in semiconductor fab. The sensor uses fabrication techniques such as lithography, etching, deposition, spin coating, and finally released to the microsensor. The core technology is protected by patents in the US and Europe. All of our actions leave trace behind, which is then screened by the security personnel. The security has to concentrate at the sampling areas that are likely to be touched by hands. In the case of a bag, this will include handle, buckle, and zipper. Post-sampling, the swipe is inserted into the system where microheater subjects the particles into rapid heating. In case of explosives, this trigger exothermic reactions which are picked up by the integrated temperature sensor of the microheater, thereby landing each compound in its own thermal signature. The algorithms use these signatures to distinguish between explosives and non-explosives. Further analysis of the algorithms help in categorization into the appropriate class of explosives. The follow-up few Nano Sniffer features. It is the first microsensor-based ETD. It detects and identifies explosives in less than 10 seconds. Identifies and categorizes explosives into different classes. Can detect mg quantities of explosives traces. It detects all classes of military, conventional, and homemade explosives. It is portable and affordable. It gives visible and audible alerts with sunlight-readable color display. Nano Sniffer, explosives trace detection technology, can be deployed at airports, railway stations, ports, malls, metro stations, corporate parks, hotels, and tourist spots. The goal is to intercept and prevent access of explosives trafficking. Nano Sniffer is 100% made in India product.
Time, you see all of us wearing the mask, and this was Union Minister of Education in 2020 because it was developed with Government of India funding. Ministry launched this as a product, and this is the system that you see standing here. And then now it's there in at least 13 airports. A lot of airports have bought it. It's the world's first ever micro sensor based explosive detector. We have all the worldwide patents for this. Now many airports are actually currently using this, and now today there is again another 300 airports will be enabled by some of these technologies. So I think this is actually picking up now. We don't have any competition for this because there is no equivalent technology for anything like this. And so now you have, now that you are able to detect explosives selectively, right? Now you can make an IoT node out of that. But the part challenge, the thing about electronics is, you can make it smaller and smaller. You can miniaturize it. Now we have been able to make it into a very miniaturized kind of a thing. And now the goal is to put it into all the transport systems, right? And protect these installations using such IoT kind of systems. But how do you power them? As I told you, one of the requirements for IoT is to the self-powering of the sensors. And again, in buses and trains, for example, there are lots of vibrations, right? At least in Indian roads, for the next 20 years, you don't have to worry about any, lots of not having vibrations. Now the question is, from those mechanical vibrations, can you generate electricity? And that's where you use piezoelectrics. And then we also did a lot of work on piezoelectrics. We have worldwide patents on the lead-free piezoelectrics right now, and this technology we licensed to Applied Materials some time ago. And so that is how the work has progressed, but everything started with an application. So most of my research, at least concerning the sensors, is you think of a product and then you put all the pieces together, you develop all the pieces together, put them all together, and then through a startup you commercialize that. That's how we have been working. And about 5 years ago, after I moved to IIT Delhi, then I started a project jointly with IIT Bombay, because my group was still in, my collaborators were all in IIT Bombay. So we wanted to develop similar kind of technologies for agricultural applications, the soil testing kind of applications. So again, we looked at the agriculture requirements. Like I told you, our idea is to look at it in a top-down kind of a fashion. So look at it, on what are the requirements in the agriculture, look at what the soil health card actually requires, and use that soil health card to, to actually develop the systems for the soil health card. So for the sensors that are required for the soil health card. So all of these are the micro, macro nutrients which farmers need to monitor in the soil, and that's what you want to develop as sensors. So between IIT Bombay and IIT Delhi, or rather IIT Delhi and IIT Bombay, we had a large project from DST to develop all of these sensing technologies. So we recently launched now a new product in the market called NutriSense. It's a soil glucometer. It can actually do nitrate, phosphate, potassium sensing in the soil, along with pH and conductivity. 5 parameters it can monitor. We started our second company, SoilSense, and now SoilSense has its operations manufacturing in Pune, while the NanoSniff does it in Bombay. And so now they are in the market now. They are training all of these village level people for testing of soil. And if you just search for SoilSense, you get to see all that's happening there. And so these are commercial products now. SoilSense has a variety of products for Indian farmers, and most of them are now in the field, and they have done a lot of tests over multiple crop cycles with the help of IARI and other laboratories. And then they are now technology providers to all of these large companies. And now after I moved to BITS Pilani, I just have got a new project approved for organic dosimeters. And this project is now a collaborative project between BITS Pilani and IIT Delhi, because I still have many collaborators in IIT Delhi. So in organic dosimeters, what we are trying to develop is, when cancer therapy, right? In the cancer, for cancer patients, radiation therapy is given, very often at the later stages of cancer, radiation is what is used to treat the cancer. But how do you measure that radiation? Whatever radiation you provide to the cancer patient, it has to match the tumor profile. Otherwise, you destroy the healthy cells, and the dose also needs to be exactly monitored. So you need to monitor the dose. You also need to monitor the radiation profile, right? and that calls for very expensive technologies today in the hospitals, which is what makes the radiation therapy a little bit expensive. What we are trying to develop is simple organic patches which contain organic transistors, and these transistors use materials in the channel which are radiation sensitive. So now, because these are all flexible patches, you can actually monitor the dose and as well as the profile, and that's a technology. In fact, in 2013, when I was in IIT Bombay, we had a US patent granted, method and device for determining ionizing radiation, and now using that patent, we are now trying to commercialize or develop a prototype with funding from Ministry of Electronics jointly between BITS Pilani and IIT Delhi. So this is what is now an activity which I am involved in. The project will run out of BITS Hyderabad campus because BITS Hyderabad is where the project work will be done. We have written lots of papers on organic transistor based radiation sensing. Now the goal is to take it forward and build a prototype out of that. So I won't get into, but a lot of good work is happening. We have published lots of papers in this area. So this is how things have been. Right, so you start with an application and then you develop all the components required, put it all together in the form of a prototype, then do field testing, then build more products, start a company and commercialize it. Because fortunately today there are lots of funding opportunities for startups, and deep technology startups, there are many companies, many VCs looking forward to funding them. They are all tired of e-commerce and IT companies. They are all looking for real technologies now. So there is no dearth of funding if you have a good idea, and but developing these technologies sometimes can take a long time and they are challenging, but I see a huge opportunity for deep tech areas from the startups point of view. These are all the things that we developed. NanoSniff is no longer a startup now, it's a full-fledged company, and the soil sense is also doing very well. They are manufacturing out of Pune, and so in all of these, whether it is materials or platforms or whatever it is, lot of integration needs to be done. So that's how we develop it. We start with the materials, we go all the way up to systems. So materials to devices to systems, that is what happens with every one of these technology developments. And so India is opportunities, right? There are so many technologies that are required in the society, and each one of them is an opportunity for a startup kind of a thing. And I mean, I leave you again back with this smile curve, saying that we need to think of such product ideas. There is enough potential available in academic institutions. If we put all our brains together, we can think of new product ideas to meet the challenges that exist in the society, and then using all the resources available, the intellectual resources available in academic institutions, if we can build prototypes, there are ways to take it forward to a product kind of a thing, and then to commercial to commercialization. So I think that's where I will leave you with. I've had a large group in Bombay. I am building now a group in BITS Pilani, but I think all of this is the work of many of my students over now 26 years in IIT Bombay, IIT Delhi, and BITS Pilani. Thank you very much.
Srinidhi, we have seen that you have most of couple of projects about biomedical applications. I want to know that what challenges are you going through when you are interconnecting electronic within biomedical application?
My only first one was biomedical. My subsequent ones, the soil health or the the explosives, there is nothing related to healthcare kind of a thing. But electronics engineers can do anything. Just yesterday somebody wants a system, an instrumentation engineer who can build a system for a water filtration system, right? I mean, once you know what are your input parameters, once you know what you need to output, you decide the circuit, right? It doesn't really matter, whether it's biomedical or anything else. But of course, the safety considerations need to be different. But if they are external devices, in the biomedical area, that they need to be more robust. Imagine you are doing some diagnosis and suddenly your circuit malfunctions, then it will create a problem. So I think the specifications, once they are provided to you, the robustness of your electronics needs to be much higher for this critical care kind of system. So,
how biosensor can differ from a normal sensor?
bio?
how biosensor can different, I mean, how
The first one I talked about is a biosensor. It's actually detecting proteins in the blood. The last one, the explosive thing, there is no bio there. It's basically exploding and measuring the temperature, right? The difference is in terms of what it takes as the input, what is the analyte, and what is the transduction that is happening. In the first case, you are converting a protein into an electrical signal, a delta R change. In the second one, you are converting that explosion, a physical kind of an explosion there, into temperature.